All right, so let's get into solving a system of equations. So the first thing we have to do is figure out kind of what is a system of equations. A system of equations definition is this. It says this. It says a set of two or more equations with the same variables. So as long as they're both x and y, or they're m and t, or g and t, depending on what you have, that we can solve them and figure out what kind of solution. Okay, there are three types of solutions. So three types of solutions that we will see. Okay, the first one is you'll have one solution. And what one solution means is that the two lines meet at one place, right? So think of it kind of like an intersection. So one solution, so here's our graph. So say one graph is like this, one graph is like this. This point right here would be your solution. So whatever that ordered pair would be your solution. So it's always your, oops, not your y, sorry, your x, y. That's how you want to write it. So that's one example. You could have something that has no solution. So again, what this means that your lines will never touch. The biggest example about this is your parallel lines. So parallel lines are examples of this. So again, I'm going to do the best that I can, graph some parallel lines. So let's pretend that this is a parallel line, this is a parallel line, and they have the same slope. So y is equal to 2x plus something, and y is equal to 2x plus something, right? So as long as they have the same slope, we know that we're good, okay? And then the third one is an infinite or / many solutions. And basically what this means is that your lines are on top of each other, or AKA they are the same line. So when you say many solutions, it doesn't mean any point on our graph is going to be a solution. It's any point, so any point that is on the line, right? So again, if I have an example, so here's my example, here's my line, and my second line is right on top of it, right? So any point, all of these points, this is a point, this is a point, this is a solution, this is a solution, all of these are solutions. So we get to just say that it's infinitely, let me rewrite that word really fast for you, or many, okay? So now that we have three types of solutions, we want to figure out what are some ways that we can solve this, okay? So three ways to solve. Okay, so our three ways that we're going to solve. We're going to solve one by graphing. This is sometimes not the best way, especially if you don't have integers. Okay, and then two is known as substitution. So those are the two that we're going to work on today. And then we'll talk about elimination on another day. Okay, these two, though, together are known as the algebraic way. Oops, spell that better. Algebraic. So algebraic way. Okay, so when we solve in that way. So we're going to first start with graphing. So hopefully you guys all got this toolkit, and it looks something like this. Okay, so we're going to be able to fill out these boxes. So we're going to fill out a box here. I'm going to do a couple examples, but as long as you put one example in here, then we are good. So anytime the first example will say we will put in this box, so just follow along and draw this. Any other examples you guys can just put into your notes. Okay, so let's go back, and we are going to talk about solving. So solve by graphing. Okay, so this is what I want you to write down. The first thing that we need to do is we need to make sure both equations are in y is equal to mx plus b form, right? So please make sure that they're in y is equal to mx plus b form. If they are not, please modify them. Step 2, graph lines accurately. Okay, step 3, what you are going to do is you're going to look for the point of intersection. And then step 4, again, this is kind of an optional step. So I'll put a little star next to it, it's optional. What I would do is I would check the solution into both equations. So that's what I would do. Okay, I would check the solution into both the equations. All right, so let's go ahead and do our first example. So example number 1. So again, all of this should go into your toolkit. Okay, so we need 2 equations. So my first equation is going to be x minus 2y is equal to 4. And so I'll put a little 1 next to that. And my second equation will be y is equal to negative 1/2 x plus 4. All right, so what do I notice? I know that this is in y is equal to mx plus b form already, so check. So what I need to do is I need to manipulate this guy. So I'm going to do it over here. So x minus 2y is equal to 4. I'm going to subtract x. So negative 2y is equal to negative x, and then plus 4. And then I'm going to divide everything by negative 2. So y is equal to negative negative, cancel out. So 1/2 x minus 2. So now I got my first equation, I got my second equation. And so now we want to plot, right? So we want to make sure that we plot our slope. So our slope is negative 1/2, and our b value is 0, 4. And then over here, our slope is 1/2, and our b value is 0, negative 2. So go ahead and plot the b value and use your slope. So 0, negative 0, 4, so 1, 2, 3, 4. I'm just going to go to 5 all the way around. 5, 1, 2, 3, 4, 5. Okay, so this will be my first one. So 0, 1, 2, 3, 4. And I'm going to go down 1. So down 1 and then over 2. All right, so my graph is going to look something like that. And then this graph, do this way. So 0, negative 2 is up here. I'm going to go up 1 over 2. So I'm going to go up 1 and then over 2. So you can tell, oops, that's very bad. I'm going to try that again. So you can tell that this graph is eventually going to cross the black graph, and it's going to probably cross it somewhere around there. So I'm going to go ahead and I'm going to move to Desmos, and I'm going to plug both of these equations in to kind of see what we get. So let's see how I do that. So come over here. So our first equation was y is equal to negative 1/2 x, and then plus 4. And then our other one was y was equal to, and then 1/2 x, and then minus 2. So what we can see is that there is a point of intersection. So again, what's really great about Desmos, again, if you need the address, it's right there. We can see where that intersection is, and we can actually highlight it. So we can see that it is the point 6, 1. So let's go ahead and let's come back and let's try to answer that question and see if that equation worked out. And we always want to plug it into the original problem. So let's go ahead, and so we're going to test out. So our solution was 6, 1. So that is our answer. So let's do a quick little check. So 1 minus 2 times 6 is equal to 4, because that should be the same equation. So 1 minus 2 times 6 is equal to 4. Beautiful. And then let's check this out. So this will be 1. Oh, I just changed this. Sorry. This is actually, this is your, I messed this up. So scratch all that. Sorry. This is your x. This is your y. So I meant to say 6 minus 2 times 1 is equal to 4. So 6 minus 2 is equal to 4. 4 is equal to 4. Check. So it worked in the first equation. So let's try the second equation. Let's make sure I don't mess this one up. So 1 is equal to negative 1/2 times 6 and then plus 4. So 1 is equal to negative 3 plus 4, and 1 is equal to 1. So notice that 6, 1 works in both the equations. So we know that when it works in both the equations, it's the solution to both the green graph and the black graph. If it only worked on the black graph, so like 0, 4 would only work for the black graph, we know that that's not a solution. So a solution has to work for both the equations. So make sure that you have all of that copied into your toolkit right here. We're going to walk through a second problem. So let's do one more example. So you can put this into your notes. So this will be a second example. So our second example will say this. We'll say 2x plus y is equal to 5. And our second equation is y is equal to x minus 1. So again, here's our first one. Here's our second one. Let's go ahead and manipulate this one. So if I subtract the 2x, this will give me y is equal to negative 2x plus 5. This does not change, so y is equal to x minus 1. So again, my slope here is negative 2. My starting point is 0, 5. My slope here is 1. My starting point is 0, negative 1. So again, best of our ability, 1, 2, 3, 4, 5. 1, 2, 3, 4. That should be enough. 1, 2, 3, 4. 1, 2, 3, 4. So again, blue graph will be my top graph. So 1, 2, 3, 4, 5. I'm going to go down to 1, 2, and then over 1. Go down to 1, 2, and then over 1. So best of my ability. Oops. Probably looks something like that. And then I'll do the red graph is right here. Up 1, over 1, up 1, over 1. So it should be, the point should be 2, 1. But let's just double check onto Desmos to see if I was correct. So again, come over here. Eliminate those two. And let's type in our new equations. So we had a y is equal to negative 2x plus 5. And our second equation was y is equal to x minus 1. So we can see there is a point of intersection, 2, 1. So again, let's just double check that this works out. So let's check in the first equation. So 2 times 2 plus 1 is equal to 5. So 4 plus 1 is equal to 5. That works out. Second equation is 1 is equal to 2 minus 1. And 1 is equal to 1. So it worked out. So again, this is our solution where both of those lines meet up.